Hi, I'm Lyra, and I make stuff like this, and this, and this. I love making stuff because it allows me to invite others into physical versions of my imagination. As creators of immersive, interactive entertainment, we're building tangible experiences that transport our guests into stories that they can touch, explore, and solve. I love teaching other people how to make stuff because, quite selfishly, I want to be invited into your great ideas. The escape room community is full of creative brilliance, and the tools to bring these ideas to life are better than they have ever been. Okay, you may say, that sounds cool, but also hard. Why should I learn to make stuff myself? I'm glad that you asked. First, making stuff ourselves is empowering. There's something magical about taking an idea that existed only in our imaginations and then holding it in our hands. It's also the fastest way to instantiate our brilliant ideas out into the world, since even if you work with other artists and fabricators, knowing the language of making helps us communicate our vision. It expands our creative horizons. As we increase our toolbox of known techniques, it expands the realm of imminent possibilities and spurs our creative ambition. When you know that you can 3D print a custom mechanism, laser cut intricate puzzles, or embed sensors into found objects, those ideas will work their way into the design constraints. It gives us control over our experience. If you can't fix it, you don't own it. Making skills are also maintenance skills, and as you develop your knowledge, you'll be better equipped to repair or replace elements as they break. This saves money and time, and keeps your room's uptime high so more guests can have a great experience. On board? Great news. The tools to do this are better than they have ever been, and they continue to rapidly evolve. We're going to race through some options on how you can run your concept through CAD or computer-aided design to CAM or computer-aided manufacturing pipelines. But truly, there are as many ways to make things as there are things to make. We'll talk about how to know when to use different methods, where to find more techniques and information, and a few best practices to consider as you design your stuff. This is going to be densely packed, but don't worry about taking notes. I'll provide links to these slides and a resource document at the end. Think of this as a resource guide, and like any encyclopedia, follow the rabbit of your attention and interest down the rabbit hole of auxiliary resources. The rest will be here for you when you're looking for new starting points. A quick speed bump. Before we dive into making, let's talk about when you shouldn't make stuff yourself, because sometimes the best making decision is not making at all. First, don't make what you can buy. If you value your time, and often even if you don't, buying and modifying COTS or common off-the-shelf parts is cheaper because manufacturers have industrial equipment and the economy of scale. As a bonus, real stuff feels real immediately, whereas we have to put in significant effort to give props the same vibe and durability. Don't make what you can customize. People have whole businesses like Redbubble or Zazzle just to get your logos and pictures onto books, banners, badges, bobbleheads, and more. Again, lean on their industrial equipment and save your elbow grease for the truly unique stuff. Finally, do not make safety equipment. This is critical in escape rooms where we're putting our guests into stories that may activate them through fear or excitement. If something is keeping people alive and uninjured, don't DIY without appropriate training and understanding of your professional liability. Purchase supplies only from reputable distributors with consistent track records and hire structural engineers to review and oversee your plans. Your player safety is worth more than anything else. Step 1, the neurons phase, the concept. The first step after thinking a great thought is to pin it down its ephemerality into something more concrete. Sketch it, make a mood board, tape a few related things together, or even write a little story about how it will be interacted with. Anything to answer some questions and help you consider the role of the object in your space. Ask yourself some key questions, such as, what does it look like? Get visual. Draw some rough sketches. What does it do? Is it a puzzle mechanism, a prop, atmospheric decoration? What does it feel like? Think texture, weight, humidity, temperature. These details matter for immersion. How resilient must it be? Can it be dropped, wrenched, or otherwise roughly handled by players? Think about how we can protect and ruggedize it. Similarly, how many cycles is it expected to go through before being replaced? A once-per-game reveal mechanism has different requirements than a control players manipulate hundreds of times as they solve. How do other objects interact with it? Consider the whole ecosystem of your room. Is it electronic? How will you include space to hold and protect wires, sensors, motors, solenoids? Will you run cables, and from where? If it's battery powered, how will you change and recharge those batteries? Think about how you can assemble it. What steps in the design will be blocked by other steps and therefore have to be done earlier? DFA, or design for assembly, is a whole field of study on its own. So give yourself grace and time to undo or redo steps as you figure things out. And critically, what else is like this? What inspiration can we take from prior art? These questions give us our first clues in the puzzle we need to solve. Materials, fabrication methods, tools, trades, these are the inputs. It may seem overwhelming, but like any puzzle, you can brainstorm, iterate, and work with your friends as you close in on the solution. You can also, for more complex prototypes, consider splitting your ideation into a looks like and a works like model. This is especially useful for anything with an electrical or software component to simplify the discovery and design processes for each part. Your looks like model has the visual, material, and industrial design of the finished product, while the works like model has the behavioral components, even if it looks like a Kraken made of Arduinos and wire. By splitting the design process into two work streams, we remove unnecessary dependencies while iterating on separate components and increase our ability to collaborate. Does stuff sort of like your idea already exist? Consider purchasing even as a modifiable base. Don't reinvent the wheel when you can cut holes in the wheel and stick magnets and LEDs in it. Could someone have already made stuff like this? Search around and you might find tutorials for near to or exactly what you're looking to make. Can we make our stuff from found stuff? As an example, for palimpsest I used a large mirror, a picture frame, one-way mirror sheeting, T-nut framing, and the complete works of William Shakespeare, all things I had lying around the house or could buy from the local secondhand or hardware store. On the note of found objects, consider keeping your family heirlooms home. Your stuff will interact with the public, a creature that often behaves in incomprehensible ways. Select objects that are durable, repairable, replaceable, and not precious to avoid regrets. When you've reached the limit of what already exists, it's time to get our stuff into digital form. Step 2, bits, CAD, or computer-aided design. Folks have already made a lot of stuff. Search Yegi, Thingiverse, GrabCAD, and similar sites to see if someone has done the work for you. You can always, usually, edit these models if you need to, and starting with something close is a great way to build comfort and familiarity with new tools. We'll break down modeling into 2D or 3D, and in each I'll suggest common file types for adding to search queries, along with a couple programs you can use to make and modify them. Canva is my tool of choice for 2D design because it is free, in browser, and is the second best tool for everything. But specialty tools are great if you're already familiar with them. Raster images use pixels and are often exported as .png or .pdf files. Use them to make pictures you can print onto things, including etching with a laser cutter. In contrast, vector graphics use lines. Look for .dxf or .svg files. These are for drawing lines and curves with a 2D laser cutter, vinyl cutter, or similar tool to follow. The beauty of vectors is that they can be scaled up or down to any size without degrading fidelity. In 3D design, there are two main methods of modeling. Parametric modeling creates precision mechanical parts and assemblies, typically saved as .stp or .igs files. I recommend Onshape to folks starting out because it is free, in browser, and does everything kind of okay. You might notice a pattern. If you get deeper into 3D modeling, especially more complex assemblies or FEA, finite and element analysis, or using the computer to see how things will behave under stress, then you can upgrade to Fusion 360, which can also be free if you jump through a few hoops. Professional tools like SolidWorks are great, but generally cost prohibitive for individuals and even smaller companies. Pro tip, parts suppliers like McMaster often have downloadable models of their parts and tools, including Swedish fish. In contrast to parametric modeling, mesh modeling is how you'll find most ready to 3D print models online, typically as .stl or .obj files. You can edit or make from scratch with software like Blender, but it does have a high learning curve. For an easier way, companies like Hero Forge for character statuettes or Charmsmith for jewelry have user-friendly interfaces to make complex models and export them as STLs. You can also buy the 3D printed models directly from them. See something, scan something. Use your phone to scan real-world objects into 3D models. Modern smartphones have surprisingly capable 3D scanning capabilities using apps like Polycam. Crayola or cardboard-aided design, the other CAD. Computer modeling is a powerful tool, but can have a steep learning curve. Sometimes it's easiest to literally shape your ideas using intuitive modeling mediums like cardboard and tape, clay, or even Legos. You can then measure or scan these models to upload them into digital form, or use them as a base or first draft for a handmade prop. Don't underestimate the power of physical mock-ups. They're often the fastest way to test proportions, mechanisms, and user interactions. Step 3, atoms, or computer-aided manufacturing. It's time to turn those bits into atoms so we can play with our cool new toys. But first, let me share the fundamental constraint of all making. Fast, pretty, cheap. Pick at most two. Not cheap. Commissioning an artisan is expensive, but you can get gorgeous work that elevates the verisimilitude of your experience. This opens the option of making really real mechanisms. This is a rare and valuable feature of rooms like Joseph Ancala, Het Testament, and The Alchemist, and can distinguish your game in a crowded market. Just be sure you have a plan if something needs replacement or maintenance and the person you commissioned isn't available. Not pretty. Rapid prototyping tools like 3D printers and laser cutters let you churn out quick objects. This is great for playtesting and iteration, but can detract from the quality of a room unless we go with the not fast method by finishing them nicely. While I'm a huge fan of using and making real objects wherever we can, for many things that may not be entirely possible or affordable. Starting the hoard. As you make stuff, you'll accumulate the necessary tools of the trade. Along with basic household items like Sharpies, glue, and craft knives, here's my short list of essential tools for any maker. Even if you don't have a full machine shop, these are a few vital tools that will dramatically expand your capabilities. Digital calipers let you measure stuff precisely so that it works well with other stuff. This is a necessary addition to your rulers and measuring tape. Precision matters when you're trying to make parts that fit together perfectly. A Dremel is an inexpensive and portable rotary power tool. You can use different heads to cut, etch, buff, sand, drill, and otherwise modify stuff. It's like having a tiny, versatile, and expandable machine shop in your hand. PPE, or personal protective equipment, is crucial because your body parts are so important. Safety glasses, appropriate ventilation masks, especially for use with some adhesives, solvents, and laser cutting, vinyl gloves, and earplugs. Don't skip this stuff. You can check your area for a tool lending library or makerspace if you want to try out further tools, but you only need them a little or before you commit to buying. Time for the lasers. When you have a laser cutter, every problem becomes 2D. It is an incredibly versatile tool. By following the vectors in a .dxf or .svg file, they can quickly etch and cut flat pieces of acrylic, wood, cardboard, leather, EVA foam, and more into custom and precise shapes. Lasers cut in 2 dimensions, but think about how you can assemble flat pieces into not flat things like enclosures or forms made by stacking shapes on top of one another. Also, EVA foam is magic. It's my favorite way to make 3D things from 2D cuts. It's robust to impact, it cuts like butter with a laser or a knife, it's infinitely formable with a hairdryer, and it happily takes finishing. Learn from the cosplayers, they know what's up. A note, be careful about materials. The wrong material can release poisonous gases or burst into flame. Because it's hard to tell the difference between different plastics, it's always safest to buy laser cut materials from a reputable supplier. and ensure that leather and wood are real, not synthetic. The Glowforge is a great, user-friendly desktop option with fantastic support and a large community of makers to back you up. They also sell their own materials if you want to be safe and make selecting settings a breeze. If you don't have access to a laser cutter or you need something a little stronger, online services like SendCutSend or Xometry are pretty great. They have access to big tools like water jets and plasma cutters that increase the range of possible materials to include everything from metal to marble while working in a similar way. They also offer larger working beds and can even do things like cut or etch cylinders or bend sheet metal. I also want to throw a little bonus call out for vinyl cutters. They seem special to use, but can be surprisingly useful in projects to elevate your production value. 3D printing. There are two main at-home directions for 3D printing. There's FDM, or fused deposition modeling, which is like taking a very precise hot glue gun and drawing it in layers to make the object you want. Many materials are available, but most often you'll be printing with thermoplastics like ABS, which is what Legos are made of, or PLA, which is what milk bottles are made of. It's relatively inexpensive, fast, and easy to work with. A great choice if you're looking to get started. The downside is that it leaves distinctive layer lines that you'll probably want to get rid of in post-processing. The Bamboo line of printers are currently my top recommendation for this category due to their user-friendly interfaces, reliability, ease of maintenance, and support community, especially for the price. The other main form of at-home 3D printing is SLA, or stereolithography. Stereolithography cures layers of resin to create strong, dense prints with finer resolution than FDM. It's slower and more expensive, but good for precision work. Formlabs makes my top bracket in this category. Want more options for materials? Check out a service like Shapeways to print things in full-color plastics, metals, flexible nylon, wax, and more specialty materials. Here's a pro tip. 3D prints are great for making molds and dies for casting or forming practically infinite copies of the same shape. You can print once and cast many. At-home 3D prints are a great way to make custom stuff fast, but as mentioned before, they don't look real. We can give our 3D printed props the Velveteen Rabbit treatment with post-production cleanup. Let's finish the job. So you've made or purchased something that looks close to what you want. How can we make it feel like the real thing? This is where the magic happens. Change the shape. We can sand down manually or with that Dremel, or pad up with Mod Podge, clay, foam, or other materials. This is great for getting rid of the visible layers in your 3D prints and making them feel like solid, manufactured objects. Change the skin. Use paints to change the surface of your object to look like anything from ceramic to hammered metal to a glowing radioactive core. For flattish surfaces, try stick on wood veneer, tiles, or wallpaper. Go to your local home improvement store for ideas. It is amazing what you can repurpose. Change the density. Fill hollow spaces, whether 3D printed or purchased, with concrete, hot glue, or sand to make the prop heavy and solid feeling. Weight is one of the most important factors in making something feel real and valuable. Change the properties. Apply conductive paint to turn your object into a touch sensor. Cover a frame with paper mache or cotton batting to make it lighter or make it diffuse light differently. Consider the impact. Finishing, like we were describing here, is often a process of putting a thin veneer over an underlying core. Consider how much punishment your stuff needs to go through and design and protect it accordingly to keep your experience looking great throughout its lifespan. Always consult the pros. Cosplayers and prop makers are brilliant at making DIY objects look amazing, and they love to share their innovations online. Look for tutorials specific to the effect you're looking for. Just think twice to ensure they'll be resilient enough. Some designs only need to make it through one shoot or convention, not thousands of escape room sessions. If you're sitting here watching this video and wishing it was for you, it's for you. The tools for rapid prototyping have never been more accessible, and the escape room community has never been more creative. I'm constantly transported and delighted by the works we lock ourselves into. Whether you're laser cutting intricate puzzle pieces, 3D printing custom mechanisms, or finishing props to look like ancient artifacts, the key is to start simple and build your skills over time. Remember, don't make what you can buy, don't make what you can customize, and never compromise on safety. But for everything else, the unique, the story-specific, perfectly fitted to your narrative objects, you now have the tools to bring them to life. Dive into the deep end, try things out, and pursue the ones that feel like your language. We're all eagerly anticipating the physical worlds of your imagination. So what are you going to make?